So now let's talk about the periodic table. So the periodic table is a table that displays all the chemical elements based on its atomic number and electron configuration. And for the chemical elements in the periodic table, they are classified into 3 groups. So the first one gonna be metal, second one gonna be non-metal, and the third one gonna be a metalloid. So in EE338, we're gonna focus on metalloid, which is semiconductor. And for the metalloid, if you look at the table in here, it's gonna have this blue color. So it's gonna be this one right here, 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 and this one right here. So those are metalloid, which is what we're gonna focus in EE338. So let's try to understand on how to read this single box in the periodic table. So let me try to zoom the box of hydrogen. So the number 1 in the top left corner represents for the atomic number, and you know the atomic number is going to be the number of protons or electrons that inside the atoms or inside this hydrogen atoms. So we have number 1, which means this hydrogen atoms only have 1 proton or 1 electron, and the letter in the middle represents for the symbol of the element. So for hydrogen, the symbol gonna be H, and underneath it is the hydrogen name, and under the name gonna be a number. So the number is 101. So this number represents for the molar mass, which we're gonna talk in the next section. So if you notice, if you go far more right of the table or you go far more down of the table, atomic number increasing. So that means if one element gain 1 additional electron, it will be transformed into a new element. So for example, hydrogen only have 1 electron, but if it gain 1 more extra electron or proton, then it will become a new element, which is helium. And for helium, if you gain more electron and proton, you become lithium, and so on. Therefore, the atomic number is unique among different elements because each element have different atomic number or number of like protons and electrons inside it. So now let's view those elements in terms of the atomic structure. So for hydrogen, if you draw it, you're gonna have a nucleus, and you're gonna have the first shell. And since hydrogen only have 1 atomic number or 1 electron, so it's gonna have 1 electron in the first shell. So how about lithium? So lithium has the atomic number of 3. So let's draw it. We have the nucleus, and we're gonna have the first shell. And we know that the first shell can only hold a maximum of 2 electrons. So let's fill that out. And since lithium had 3, so you need 1 more electron in the second shell. So we're gonna have a second shell, and the last electron gonna be here. So this is gonna be the lithium representation. So how about sodium? So we're gonna have nucleus, and sodium have the atomic number of 11, which means 11 electron. So let's draw the first shell, and you can only have 2 electrons in the first shell. So we got 1, 2, and is it 11? So you gotta have like 9 left. So let's draw the second shell. So the second shell can only hold at most 8 electrons. So let's fill it up with the total of 8. So 8 plus 2 is 10. So we have 1 more electron left, and that's when we're gonna have the third shell in order to accommodate that last electron. So last electron. So what do you see the general pattern of those 3 elements? So you can see that for hydrogen, it only have 1 shell, but for lithium it has 2 shells, and for sodium it has 3 shells. So that shows you that if you go down vertically in the periodic table, your element gonna increase in size or in radius. You can see in here you have 2, and in here your radius increase to 3. So if you go down vertically, your element gonna increase in size or the radius. So you have this small size, and then you increasing to this big size, increasing increasing and increasing. So we already know how the element gonna grow in the vertical direction, but how about the horizontal direction? So let's say we have lithiums, and I still keep the lithium atomic structure in here. So let's say you go to carbon, which has the atomic number of 6. So that means from lithium to carbon, you have to gain 3 more extra electrons. So let's draw the structure of the carbon. And we know that the first shell can only hold 2, and the outer shell can only hold 8 total of electrons, so it's enough for us to fill the last 4. So this is gonna be the complete atomic structure of the carbon, which has 6 electrons. And if you notice, the shell number doesn't change. It still had like 2 shells, 1, 2, 1, 2. So that means if you go horizontally, the shell number doesn't change. But if you go more, you will gain more electrons, right? That means you also gain more protons in the nucleus. And because you gain more proton in the nucleus, therefore it's gonna cause more attraction force between the protons in the nucleus with the electron that orbiting around it. So it's gonna have more attraction force. So the more you go horizontally, the more you're gonna have more proton, and if you have more proton, it's gonna attract all the surrounding electron. And you know that the mass of a proton is bigger than electron, right? Therefore, the proton is the one that attracts all the small electron around it. And because it attracts all the surrounding electron, that means the size of your elements gonna shrink down. Therefore, the size getting smaller and smaller and smaller and smaller as you go horizontally in the periodic table.